Welcome to an overview of the RAOB program's fog index and predictor configuration table. RAOB's fog prediction system can be configured to predict both radiation and advection type fogs. But before discussing this system, it is important to note that RAOB's classic data display only displays the traditional fog prediction indicators as seen here. They were developed for the European region and only apply to radiation fogs, and they are not configurable. These three fog parameters can also be listed on the custom data listing, which will now be displayed. In here you can again see the same three classic fog indicators, and just below are the new fog indexes, one for radiation fog and the other for advection fog, where the percentages represent the probability of the respective fog events. You can also view the fog probabilities graphically. To do this, just use the Displays menu and select the Fire and Air Quality diagram. In here you have a split fog nomogram showing the radiation and advection indicators. You can also see the details behind the fog probabilities by selecting the menu bar's Listings option, which has a fog table and displays the 78% and 65% probability values. But we'll get back to this display a little later. What's important now is to see how to configure your RAOB to best reflect radiation and advection fogs for your environment. We do this with the fog index table. There are three ways to get there. One is to click on this Configure button. Another is to right-click on the fog nomogram, where we again see the two fog probabilities, and where you can click on this button for the fog index table. And the third method can be found with all other configuration methods through the Options menu, where you can select the fog index table. We now see the fog index and predictor configuration table, where you can customize fog parameters for your local area and season. Please note that these table predictors can only be modified if using the optional analytic module. Otherwise, all values remain at their default settings. This table works in the same fashion as does the severe weather parameter table, where the weighting factors can range from 0 to 10, and the mid-range probability values are specified here. The main difference between the severe weather table and this fog table is that this fog table actually has two tables, one for radiation fog and the other for advection fog. Regarding the weighting factors, notice that 5 of the advection fog parameters have a 0 weight. This is because they are normally only used as radiation fog predictors. However, these are just the default values, and the user can include or remove any parameters as required by local rules and conditions. Also remember that weighting factors can range from 0 to 10, and if used, those higher weighting factors will give those parameters relatively greater weight during the final averaging process. Regarding the mid-range probabilities, these two columns of values define the lower and upper limits of the mid-range probabilities. For example, looking at the surface wind speed parameter, the mid-range probability is defined by the 6 to 9 knot wind speeds. So, if the actual wind speed was 6 knots, then the wind speed parameter would produce a 33% probability of fog occurrence. If the wind speed was 9 knots, then it would produce a 67% probability. RAOB determines the ranges for the low and high probability limits with an internal algorithm, which extends the mid-range spread by the same amount in both directions. In this case, there is a 3-knot spread. Therefore, the upper limit of the high range would be 12 knots, and the lower limit of the low range would be 3 knots. As a result, if the wind speed was 12 knots or greater, then a 100% probability would be produced, and for wind speeds 3 knots and less, a 0% probability is produced. You should also note that the trend of the range is also important. For the wind speed example, the trend is positive, since the mid-range values are from 6 to 9 knots, which means higher wind speeds produce higher probabilities. Now let's look at the temperature dew point spread parameter. This has a negative trend, where the mid-range values are from 4 to 2 degrees. This means smaller dew point depressions result in higher probabilities. For example, a 0-degree spread results in a 100% probability, and a 6-degree or greater spread results in a 0% probability. Let's now look at some special cases. Here is the cloud cover parameter. Because RAOB estimates cloud cover as a function of fourths of sky coverage, only the values of 0 through 4 can be used. There's one more unique parameter to mention, and that's only seen on the radiation fog view. Notice that this wind speed parameter uses 4 boxes to define probability ranges. This is because, unlike advection fog, many studies show that radiation fog needs a certain limited amount of mixing, not too much and not too little. So in order to configure these conditions, the middle 2 boxes actually define the high probability range, where values of either 5 or 8 knots produces a probability of 67%, and a speed of 6.5 knots results in a 100% probability. On either side are the mid-ranges, defined by 2 to 5 knots and 8 to 10 knots. Therefore, a calm wind produces a 0% probability, and winds of 12 knots and greater also produce a 0% probability. Okay, now we'll look at the other tab of parameters, the special predictors. They list the same 3 predictors for both the radiation and advection fogs. All 3 are initially set to a 0 weighting factor because they cannot be predefined since they are so unique to local conditions. First is the hours predictor. Here you decide which hours of the day best predict fog occurrence. They are local hours, and they are individually weighted with values from 0 to 10. If this predictor is used, then it is very important to configure the UTC time offset with this button. Next are the seasonal or month predictors. Here you decide which months are most fog prone, and weight them accordingly. And the last predictor is the surface wind direction. Here you decide which points of the compass best predict fog occurrence. Before closing this video, let's go back to the sounding diagram and call up the listings displays. And let's look at that fog table again. Here you can see at a glance all the predictors used to produce the resulting radiation and fog summary probabilities. You can also see each parameter's weighting factors and their individual probabilities according to the low, mid, and high categories. That completes the fog index and predictor configuration table video. Thank you for watching.